So we can start. First of all, thank you for a very interesting talk. Mine is going to be much shorter. And one thing that I learned apart from expedition is that St. John's Day is celebrated not in one country that I know, but more. So I didn't know that. Anyhow, but going into the talk now, a few abouts. And the mandatory blurb about me is that I work as head of engineering at a startup providing digital marketing recommendations. It operates mostly in the United States, but has an engineering team in Lithuania, where I am from. Before that, I worked at some better known companies. And if you like to read, I'm trying to come back to regular blogging. And finally, this is my first attempt at public tech talk circuit. So if anyone would like to give feedback, I would be very happy to listen. About the talk itself, these slides were part of a bigger deck for internal knowledge sharing. The talk is named mocks, but the gist will be on how mocks relate to test scalability and code maintenance. Most of what I will talk about comes from experience, but there are some parts where I myself am actually a recent convert. In the end, I will share a few day-to-day pitfalls related to mocks that may not be obvious to anyone who is starting out. So I hope this talk will have some useful tidbits for varying ranges of experience. And so mocks. In terms of test maintenance, avoid mocks as is reasonably possible. Mocks are deceptively easy to use, but for the long-term maintenance, they will become a source of waste. When it feels like working with the tests takes longer than actually implementing the feature being tested. A good test should verify that given a set of inputs, expected output can be observed. In most cases, it should not really care how the code under test implements it. So the first problem with using mocks is they leak implementation details into the test. For example, to test that a function A calls some function B, it is very easy to replace function B with a mock. But imagine 10 tests like that, and a change comes, removing B. And it will require updating those 10 tests, when in fact it actually should not. The second problem is evident from the previous example. Using mocks focuses the test case not on the behavior of the function contract, but on the fact that mock is called or not. And if the mocked out function, the B in the previous examples, changes, the test just won't catch it. So what are the alternatives? And well, using the real thing underneath the tests would give the most confidence that the thing works, but it is not necessarily always viable due to performance or complexity or some other reason, in which case writing a fake that is tested to have an API matching as closely as possible to the real service is probably going to save a lot of time for you. Stubs suffer largely from same problems as mocks. They do very similar things, and it is very hard to ensure that they behave as the real system or as a fake. But mocks must serve some purpose, because otherwise why would there be a part of the standard library or have popular packages? So let's take a step back and think of what types of code can be under test. And here's one way to answer this at a very high level. State changing code that produces side effects and changes the state of the system. For example, send email, save a record. And non-state changing that most often just returns information like get user or get a file. I hope the idea is quite clear, as it will become relevant in the next slide. So the answer to the question before, when to use mocks, well, use mocks when you need to have some dependency return a value to get a state changing function into a specific state, but only when a real or fake dependencies are unavailable. And coming back to the terms from the previous slide, state changing and non-state changing functions, it does not really make sense to test non-state changing functions using a mock. Consider this, that if a function getUser returns user object, has database query results mocked out, what does it test? It actually just tests that the mock and return statement were called. Hopefully I planted the seed in your mind about not using mocks, but you just made the trade-off and have to use them. So here are three most common pitfalls. One of the problems with mocks is they do not check the interface contract. This means in the test, anything could be passed as a parameter and everyone would be none the wiser until something breaks in production. As you can see, the test actually passes, whereas assume this is production part breaks. That is because the mocked out function did not test past parameters. However, this issue is an easy fix by passing autospec through to the mock constructor. It will do a basic check if the inputs conform to the function contract in terms of whether required positional arguments are passed, whether no unknown keyword arguments were passed, and similar. It will not check types though. Second pitfall, and an easy way to spend more time looking at the test output than necessary, is by using mock.any placeholder. So because it shows the difference between two asserted objects. When you test the real data and expected data, it actually compares string representations of those objects. So in this example, you can see that two differences are reported, where C and B and any and D. However, in reality, there is only one, C and B, because any would match D. And this example is quite innocent and trivial, but anything more complex, very big hierarchical dictionary that you need to just skip parts of, and it may waste a lot of time, talking from experience. And finally, the most frequent quote related to Python mocks is probably mock the right thing. It is also one of the easiest to get frustrated about. And in here, there is an example service module and example test module. And as you can see, the first test function tries to mock the right thing, but it will not work. And the second example mocks the function in the module, in the service module, where it is used, and it does work, but it prevents reusability of this mock and will most likely lead to a lot of copy-pasted but slightly adjusted code. And the reason this is happening is because at the top of the file, the service.py, the function getScore is imported into the module scope. And when run calls it, for all intents and purposes, the getScore function is part of the service module, not the project shared.utils. And I won't go into details about Python scope, but I really recommend reading the documentation on that and getting familiar with it. A lot of things will become clear. So how to fix this? Thankfully, the solution is quite easy, which means mock the right thing. and it means import module and call the function on the module. I hope you can see the difference here. And the reason it works is because the function is called through a module reference. So instead of function being inside service, we take utils and we call the function on utils. And the example test that you can see here, it actually mocks the function inside utils, and it actually works. And that is it. And sorry for a slightly abrupt ending. One thing I would like to acknowledge is that I was actually a big fan of mocks until very recently, and converted after reading this excellent recently published book from Google. So if the talk somewhat disappointed you, I hope this free book recommendation will pay for it this time many times over. And apart from that, I look forward to your questions and feedback. Thank you.
Very much, Julius. So does anyone want to post a question in the Q&A? Do you have a question, Marco?
No.
I think it was very clear talk. I have one other suggested resource on that third problem you're talking about why your mock doesn't work. There's actually a blog post that I always point people to by Ned Batchelder called "Why Your Mock Doesn't Work." I'll post the link here.
Excellent.
Okay, while we are waiting for questions. Oh, we have a couple of questions. Actually. Okay, one suggestion from Thomas, no question, but useful tips, thanks. Then Gregor.
Tom Granger.
Okay, I think
these are just in the wrong chat box.
Yes. Oh, from Dom we have, what is your preferred testing framework now?
PyTest. And in the mocks that I have used, I actually use standard library mock patch utility. However, so only recently went back and skimmed through PyTest docs and relearned again, I would say, about monkey patch, and I actually find it very useful and very easy to use. But like I said, I changed my ways recently and tried to avoid mocks and tried to talk my team into using fakes. And it did not require a lot of convincing as well. Everyone's seen the benefits quite quickly.
Could you give us a little bit more information on what inside this Google software engineering book convinced you?
I think the main insight that made me change my mind was that I actually noticed a couple of times where people would do one very trivial feature and then actually spend time changing 20 tests, because we have quite high test coverage, and I just didn't like it. And at the time, I just didn't know how to solve this. And in this book, there is a whole chapter dedicated to testing, unit testing, and actually large integration tests. And one of those chapters had very, very convincing arguments that basically, one way to avoid this requirement to go back and change all the test cases is to use fake. And remembering my experience in Lifeline, we had used fakes a lot. And as long as they match the real thing, you do not have to go through all the tests changing them.
Nice. We have a question from Adam Steele. Oh, well, do you want to do these questions, Marco? You start.
I have to say, yeah,
Okay.
question from Adam. I have to say this is a classic interview question. So like, yeah, take note if you are like looking for a job right now. What are the main difference between mocks, fakes, and stubs?
So I don't know if you still see the screen, but I anticipated this question. I don't know if I have to read it to everyone, but you can make a screenshot. I will maybe try and share this slide deck later as well. But this is the difference.
Mm-hmm. Okay. Yeah, another question from Agby. Can you give one of two problems that you experienced with mock?
So, like I said, one problem was that our test coverage is quite high, and we use mocks a lot, which meant that any small change to the implementation would require updating a lot of tests, essentially 10, sometimes 20. And this is just time wasted because not time wasted and a noise, because you make a change, you implement a feature, and you usually test it yourself and can't tell whether you covered a lot of edge cases or maybe it's good enough. And then we're having to go back and fix 10 or 20 tests just to make the tests work is just an unreasonable waste that should be removed. And this morning I saw an excerpt from Ken Beck post. Ken Beck works at Facebook and is quite famous programmer, and something from that excerpt really struck a chord with me. He said that at Facebook, if a test fails and the system still works, they just remove the test. And maybe I'm not that radical, but it does give food for thought.
Mm-hmm. Well, yeah, on this subject, I don't have a question, just want to share my opinion. I think that the golden rule with mocks is to test external dependency. Like for me, the classic example of mock is when you need to use an HTTP library to call an external endpoint. You can mock that because that's external to the system, but